Pranay, are you there? Pranay? Pranay? Do you hear me?
Allow mic. Allow camera. जी सर.
हेलो.
हाँ सब हो गया. हाँ हाँ. क्या नाम है? किस नाम से है? प्रसन्नजीत. नहीं हमारे में नहीं है. वेटिंग में शो ही नहीं कर रहा है.
Hello.
Yes, Pranay.
Am I audible?
Yes, you're audible.
So I'm still not able to share my screen for the PPT.
You are facing problem in sharing the screen.
Yeah, only meeting organizers and presenters can share it showing.
Now you can check, please.
Is my screen visible?
Yes. Divya ma'am.
Should I start?
Wait for 1 minute only, please.
Okay.
Divya ma'am, are you there? Divya ma'am, are you there?
I'm muted, sorry. I'm muted. Yes.
Okay.
Yes,
okay.
sir, I'm here.
Okay. Am I audible, Divya ma'am?
Yes, sir, you are audible.
Okay. नहीं वो दिए दिव्या मैम.
Yes, sir, I'm
Okay.
here.
Ma'am, with your permission and with our second session chair, Mohammad Sadat sir, with your permission,
Sure.
can we start our session?
Sure. Please start.
Okay. So good morning to all of you, and welcome to the International Conference on Advances in Science, Engineering and Technology, organized by Department of Computer Application. This is our second day, and it's a technical session, and we are having a session chair as Dr. Divya Sharma. He is an assistant, I suppose, associate professor. Yes, ma'am. If I'm not wrong.
No, sir, I'm assistant professor.
Okay. So hopefully you will be associate professor and professor. So we are having Divya ma'am she is from IIT Lucknow, and right now she is the session chair of our technical session. And next we are having Mr. Mohammad Sadat. He is an assistant professor in Department of Civil Engineering in Degree University Lucknow. So I will be starting the session. And our first presenter is Mr. Pranay Kohit. His paper title is Development of a Bike Speed Regulator for the Enhancement of Rider Safety Using IoT. His paper ID is 118. Pranay, you can start your presentation.
So a very warm good morning to everyone present here. I am Pranay Kohite of Vishwakarma Institute of Technology, Pune, and I am here to give you a detailed overview of our research paper titled Development of a Bike Speed Regulator for the Enhancement of Riders' Safety Using IoT. So here is a brief outline of our presentation. We'll start with the introduction and move on to the proposed model, and followed by the results and discussion and conclusion. So to give you an introduction about the topic, Safety systems in automobile industry has made great leaps and bounds, which has led to a significant reduction in accidents. But this progress has is not equally distributed. What I mean to say is that the safety systems in four-wheeler automobiles has made great progress, but the same cannot be said for motorcycles. While there are safety systems such as anti-lock braking system and traction control systems in motorcycles, they do not address and contextualize the dynamic traffic situations faced on a day-to-day basis. This has resulted in a great number of accidents involving two-wheelers and motorcycles. So this highlights the need for an advanced collision detection and avoidance system, which we have addressed through our project. So coming on to the proposed model. Uh, so our model basically has three systems. One is the distance detection system. This uses ultrasonic sensors, which are utilized for real-time distance measurement, and this is processed using our control algorithm. Next, we have the braking system. After the distance is detected, we use the control algorithm to ensure that the braking is done properly. And the last is the accident notification system. So this system detects falls and impacts. And if let's say there is an accident, it will send a mail or a SMS or a call to the registered emergency contact. So ultrasonic sensors first detect the distance. Then we use a control algorithm which factors in the speed of the bike and the distance between the object and the bike. So a brake is only applied when when they when at a particular distance the speed is more than that threshold. This is the basis of the working of our control algorithm. So the braking system in our prototype features a simple gripper mechanism for effective braking and control. We have used the potentiometer to vary the speed, and for as for the accident notification system, we have used an accelerometer to detect the tilt. So let's say if the tilt is more than a specified angle, then it sends a notification to the registered user. So results and discussion. So we rigorously tested our prototypes, and the ultrasonic sensors are giving us real-time distance and braking. So there is very less delay between the distance detection and the actual response time to brake. It was high at first, but we have reduced it. And for the future scope, we we are working on computer vision for obstacle classification using YOLO. So what I mean is, let's say there is an object in front of us, but it's a bush or something. So we don't need to brake in that case. So that is our future scope. Thank you.
Thank you, Pranay. Divya ma'am, do you have any question to ask?
Yes, Pranay, I do have a question. First, let me tell you what preventions you have taken for the jerk, if in case it happens in your vehicle.
So ma'am, we are making a system that works in already existing with the anti-lock braking system. So that takes care of the jerk. The
Anti-lock braking system.
anti-lock
You were
braking
talking
system.
about some. You were talking about some vibration sensor, I guess, in between. What was that? Or something else you have used the word?
No, ma'am, vibration tilt sensor for
Yeah, yeah,
accident
it was the
detection.
tilt center. Okay, tell me something about more about it.
So basically, the tilt sensor, we measure the tilt in the z-axis, x-axis,
Okay,
sorry. So when it crosses a certain angle, then we use the
roughly
ESP.
roughly what angle?
So we can set it anyway, but for now in our prototype, we have used it at a 45 degree.
Okay. Why you said 45 degree? Do you have any answer for it?
Because while turning, there is always some tilt in the bike. So it wouldn't make sense for us to send a notification at a lower angle.
And
This
please,
accident,
uh,
this
okay, carry
accident
on.
detect, yes, this accident detection system is
Mhm.
only when an accident happens. So it wouldn't make sense for us, as I said, to send a notification below the angle of 45 degrees, we think.
And another thing, tell something more about your vision or the future scope. You were talking about the YOLO.
Yes, ma'am. So we are currently working on that. So basically, we will classify objects into safe, hazardous objects, something like that. So we are working, we're not quite sure how to implement it right now.
Okay, fine, Pranav. Thank you.
Thank you, ma'am.
So, Pranay, is your study theoretical or have you done some kind of simulation or some kind of traffic data? Or is it only a framework for how you perform the?
We have made a hardware prototype.
So there is no simulation,
No, not yet.
and there is no methodology explained in your presentation. How will you perform that thing? Because you have not explained the specification of bikes which you'll be using and its limitations and expected results. Do you have
The
anything?
I'll show you your prototype also. Its picture also.
yes, ma'am. Just a minute.
Because if you are applying something on a system, a traffic usually is a stream. So there are multiple vehicles around a single bike. So what happens to other bikes if you implement the system? So you have to perform simulation, maybe in MATLAB or some other tool. Then you can proceed with your study. With a
Yes, yes.
single, yes, sir. Thank you.
Thank you.
Thank you, Pranay, for your presentation. Next, I would call upon Ms. Bhageshri to present his paper. Bhageshri, are you there?
Yes, sir. Yes, sir, I'm there. Sir, please give the permission to screen share to Abhishek Rana, who is present in the meeting.
Now you can share. You can share your screen now.
Sir, just give the permission to Abhishek Rana to share his screen.
Abhishek Rana.
Yes,
Okay.
sir. He is the meeting room.
Okay, okay. I have given a permission. Please proceed.
Okay, sir.
Her paper title is Street Light Automatic Intensity Controller using Arduino UNO, and her paper ID is 125. Bhageshri, please
Okay,
share.
okay, sir. Abhishek, please screen share the PPT.
Allow mic.
इधर chair है
Not yet.
Yeah. Oh yeah.
Yes, sir. Now full screen.
Yeah.
Good. Now it is visible, sir.
Yeah, it's visible. Divya ma'am, is it visible? Okay, you can start.
Okay, sir. Good morning, everyone.
It is visible.
Myself, Bhageshri. So our project name is Streetlight Intensity Controller using Arduino. So over here, our co-author names are Naveen Kumar Binsar, myself Bhageshri, and Akansha, Praveen, and Abhishek Rana. We are from JSS Noida Electrical Department. Now moving ahead to the next slide. So basically, we are going to give you the introduction of our project. Then we will move ahead to the objective, where we'll give you the brief idea what was our goal behind the project. Then we move ahead with the system architecture, where we're going to discuss the each and every component of our project. Then we move ahead with the working principles, where I will show you the what basic idea and terminology behind our project. Then we move ahead to show the photos of our prototype. Then we move ahead with the flow chart and algorithm. Later on, we will discuss result and discussion and conclusion.
क्या
Yes, sir.
डीन से बात करो, वहां पर बात करेंगे, यहाँ मीटिंग चल रही है। कल बोला था ना
Now
डीन से
moving
बात करो,
ahead
बात
with the
करें
next
विशाल सर
slide.
से। इनसे
So,
बताओ यार।
when we talk about the introduction, basic agenda of our project is to make such a system which can sense the lighting system of environment, and the basis of it, it can automatically control the brightness of the street light, which will give us three benefits. First, it will use energy efficiently. Such system will make the use of energy more efficiently, and it will save energy also. And second one, it will not impact environment by less lighting pollution. And third one, it will cost effective also. These are three major goals which we'll be discussing in the objectives as well. Now moving ahead with the next slide. Next slide. So basically, the objective of our project is to make the system which will save the energy. By saving energy, we can use the energy efficiently. As of India has a major population, so it is not easy to give energy to each and every person out there. So basically, we can save energy so that we can use energy more efficiently. So by using our project, we can save energy and make the system very cost effective, because the component which we use in our project are lesser in cost. And third, which is the basic most important, the environmental impact. The environmental impact of our project is lesser, because we have used LED in our project, which will be giving less lighted pollution, and no pollution will be done by the LEDs. Now moving ahead with the next slide. Now we're going to talk about the system architecture. System architecture, in this section, we will talking about the each and every component we used in our project. First, we use Arduino UNO, which is basically the brain of our system, which will control how the signals flow in our system. And each and every decision will be take according to the program we fed it into the Arduino UNO. Second, we use the MOSFET in order to control the gating signal provided to the Arduino UNO. Basically, we have to control the alpha cycle, which is T on by T off, by we can control the brightness of the street light. Third one component is MOSFET. No, sorry. Third one component is LDR, which is going to sense the level of lightness in the environment and send it to the Arduino. Fourth component is IR sensor. Basically, it will sense the object in the road or not. Now moving ahead with the next slide. LED. LED is the basic lighting element we use, because it has three elements which we needed. First is energy efficient, and cost is lesser, and less environmental impact. Now moving ahead with the next slide. Now basic working principle. What is the working principle of our project? Is basically we are using three major components, so LDR and MOSFET and Arduino UNO. So basically LDR will sense the lighting level of the environment and send it back to the Arduino. And now we can control the gating signal of the MOSFET by using the T on and T off, which we have already fed it in the program. By we can control the voltage supply to the Arduino UNO. By controlling the voltage supply to the Arduino UNO, we can control the brightness of the LED which we use. So basically, we use two system over here, two components over here, LDR and the MOSFET, in order to control the brightness level of the LED in our system. And we have also incorporated IR sensor in order to switch off the light when there is no vehicle on the road, and switch on the light when there is a vehicle on the road. So Now moving ahead with the next slide. So this is basically prototype for our project at the college level. So basically, A is A prototype shows when there is a light. So there is no need to switch on the light. And B prototype is basically the intensity of the light is 30%. We can also vary the intensity of the light to 30 to 80% according to the requirement in the nature. So basically, we have given one picture only of 30% brightness. We can also edit some more pictures to show you brief idea of, but I am not aware of the project because project is not at my place right now. Now moving ahead with the next slide. Flowchart. Now, basically, we're going to give you a brief discussion of the major important part. Now, moving ahead with the first, you have to read the LDR status. LDR status is talk about the light in the nature, and it is a scale 0 to 255. Up to that, we can just send to the Arduino Uno, and basically what we have discussed in the basic principle is going to the same in the flowchart as well. So according to the signal from the MOSFET and the LDR, Arduino will itself will decide to control the brightness. It's all the same. We're not going to waste ahead in the flowchart. Now moving ahead with the next slide. Algorithm is basically I'm going to use if else only to make sure all the IR sensor and LDR work properly. So basically in the first five lines we have described the basic component and in order to display the all reading in the LCD so that we can check on whenever needed what reading has to be of the brightness and all that parameter has to be displayed. So basic five line are for the LCD display. Now moving ahead with the next slide. So in next slide, we decided at what time we have to on the light, at what percent we have to on the light. If the light is less than 20%, and signal is basically sensor one and sensor two, which we refer for the IR sensor one and IR sensor two, which will tell us there is a vehicle on the road or not. Up to from that reading, we can decide to set the intensity low or high. So for that, we use this if else basic programming, not so hectic. Now moving ahead to the next slide. The days are also same programming overwritten here, but the major changes over there is the delay of 100 microsecond because it can fluctuate very. For that we don't need, so we added the delay at the last. Now moving ahead with the next slide. Now moving ahead of talking about the result and discussion. So basically, we made the such advanced streetlight intensity controller. How it is benefiting in the terms of three major parameter: energy efficiency and operational cost and environmental aspects. We have discussed in this slide only. So basically, when we talk about the energy efficiency, we are saving energy by switching at that time whenever needed. So we are uh, lower down the energy operational cost by using the component which are lesser in cost. Third, a very important aspect, environmental impact. We are using LED for that, which will lower the environmental impact by having a lesser light pollution in comparison to the all the lighting element out there in the our world. Now moving ahead with the next slide. So that's all. We like to conclude all the project details over here only. So basically, major goal was to save energy and utilize energy use efficiently. We can do it by our project prototype. That's it. Uh, now, thank you for all the support. Sir, any query, any question from my side, from your side?
I have a one question. Do tell me how your LDR is supposed to give you most energy efficient performance as you state this.
Basically, ma'am, we are not using whenever whenever we need light, we can switch on dynamically. So, like today lighting system, it's all on time. Uh, Whether you talk about daytime and nighttime. In night, when we talk about it, all on from 6 to 12, from 6 p.m. to night up to, they all on. So now by using our project, we can control the brightness. Brightness is controlled by the voltage supply. So we are using less voltage to on the light. By using less voltage, we can lesser down the power requirement of the LED. By using lesser power requirement, we are ultimately saving the energy. That's all.
Okay, thank you. Can you tell me the range of in which range your LDR displays light or emits light?
Basically, ma'am, we made the prototype which work ultimately to 15 to 30 centimeters. That's it. We can also arrange, if we want to give it to the higher level, we can incorporate a small model at the both side of the road. But ultimately, it will not go that beyond to the project at the higher level.
Okay, thanks, Rakesh.
Hello. Uh,
Yes, sir.
uh, Bhageshri, have you considered the Indian Road Congress codes for the intensity of lights? Because it is defined by these codes how much intensity should be there on the lights, on the street lights, on the highway lights. So have you
Not
considered?
yet, sir, because we have just made
You
a
can
small
implement
prototype.
your prototype if it does not satisfy the codes of Indian highways. So you should consider that part. And
Yes, sir.
I would suggest you not to include the program codes in your presentation. You
Okay,
should
sir.
only present the outline or let's say flow chart,
Okay,
summary of your code. It is not recommended. Okay.
okay, sir.
And please next time present the data. How much energy have you saved? Like what is the
Consumption.
expected result? And have you considered the initial cost which will be incurred in
Sir, initial
the system?
Mhm. Just when we were going to make it, the initial cost was about 2,000. That's
You cannot have guesswork in these kind of research. You have to present data in form of some charts, some percentages. Then
okay, sir.
it has some weight. Okay, so next
Okay,
time please be prepared. No,
okay, sir.
thank you.
Thank you, sir.
Thank you, Bhagishri, for your presentation.
Thank you,
Now,
sir.
I would like to call upon Mr. Bhaskar Shriranjani. Mr. Bhaskar? Mr. Bhaskar, are you there? Mr. Rahul Pachori? Mr. Bhaskar? Mr. Rahul? Hmm. Mr. Kumar Saurabh?
Yes, good morning to all of you. I'm here.
Good
Can I
morning.
start my presentation?
You can start your presentation.
Thank you so much for allowing me.
You can share your screen.
Yeah. Just wait for a while. Is it visible? Is it visible?
Yes, it is visible. You can start.
Good morning to all of you. I'm Kumar Saurabh. I'm the research scholar here in the same university, organizing this conference in the Department of Computer Science and Engineering. And this is my review paper. And here I have tried to gone through with uh, recent researches and to find out in which direction we can move and what different areas are still a little bit explored or unexplored by integrating different advanced technology, cutting edge technology with Internet of Things, so that the industry will move from 4.0 to 5.0. The title of the project, title of this presentation is IoT and Machine Learning, Further Research Access from Industry 4.0 to 5.0. So in the content, I have a very small presentation, because as it is a review paper, I have no different model and different things. So it contains only introduction, review, the sensor and the classification and the IoT application, use sensor and smart devices, and then industry 4.0 to 5.0. And in the conclusion, I have tried to explain that how to integrate different cutting edge technologies and the unexplored area, still unexplored area, which is not like a little bit touched and or yet not touched. As we all know that the Internet thing is what it is, an interconnected network of devices that share resources without human intervention. Right. And these system comprises various processing and computing devices, applications, or living beings. And all these items should carry, a distinct ID to enable data mobilization, over a network without any physical or mechanical intervention, and action led by human or machine, respectively. So in such a network, various tangible items like can communicate with each other over internet, and intelligent gadgets and their associated smart devices are like interconnected through a network, and enabling them to operate with greater efficiency. Right, though the IoT, represents a significant future advancement in internet technology in human life. Uh, Review highlights of like whatever I have studied, around 50 to 60 papers. The review highlights are different governments of different countries are actually focusing on implementing intelligent currently prioritizing the implementation of intelligent initiatives with their nations. To achieve smart country, the initial stage to ensure that each city is smart. These entails making every financial institution, home, education, farm, and law and order, smart and intelligent as well. The implementation of these technology requires actuator and sensor-based appliances, and to enhance the excellence of life for individuals and organization, the innovation facilitate new interaction between people and various devices. So if if we just go through with a little bit of history of that, though, the industrial sector, like uh, industrial uprising, there have been three basic industrial uprising referred to as 1.0 industry, 1.0, 2.0, and 3.0. And now we are at 4.0 and trying to move towards the 5.0. So the first industrial uprising at the end of 18th century was signified by using use of mechanical production amenities. And in 2.0, spanning from 20th century to late 1980, witnessed significant increase in the quantity, quality, and diversity of industrial products. And and in 3.0, information, raw data, and programming logic were employed to mechanize different processes. Despite the prolonged duration of these processes without human intervention, there is still human factor a little bit involved. But in Industry 4.0 combines the simulated and physical world, facilitating the interconnection of devices and data. The Internet of Things is transforming industries by merging simulated and physical world affecting automotive and industrial industry. The data that I have collected from various sources, from various research papers, that the number of connected IoT devices globally is projected to reach 75.44 billion by 2025. And with a significant monetary impact ranging from 2.8 trillion to 6.1 trillion, like in around threefold, around 2.2 or 2.5 fold. Uh, uh, by 2025, it is projected to create 12 trillion in yearly income and working reserve, approximately 11% of the global economy. Sectors such as transportation, healthcare, manufacturing, retail, and are increasingly adopting IoT devices to improve prolonged monitoring, decision making, and action initiation. So, how these sensors actually work? Like physical values, like different level for in terms of like how level sensor, how IR sensor, or how proximity sensor, how humidity sensor work. The physical values are sensed by those sensors, the physical changes and processed into electric parameters like voltage and frequency, and that is called a signal and captured by the actuator, and then the actuator then react accordingly. So here are the different classification of sensor. Like sensors are initially divided into two groups, digital and analog, then further divided into vector and scalar, and finally categorized into passive and active groups. Right? Like these are the basic things about that. Coming to our part, that IoT applications use
Kumar sir,
sensor and
please make it fast. Kumar sir,
uh,
please make it fast.
yes sir, yes sir.
Please.
Like different applications like smart city, which require multiple sensor and different smart devices are already available to uh, to work for smart city and transportation, enabled IoT enabled house and intelligent secure premises, enabled industry security, health, fitness, intelligent farming, and financial firms like factories and all that. So how we are moving from 4.0 to 5.0. And these two are the last slides just to go through with that. The Internet of Things is a network of connected devices and gather and disseminate information. It has evolved into the Internet of Everything, then Internet of Nano Things, and Internet of mission critical things for disaster management, battlefield rescue operation, and Internet of mobile things. So moving from Industry 4.0 and 5.0 have transformed manufacturing process, focusing on human-machine collaboration, personalization. So for Industry 5.0, we require to combine AI, IoT, and advanced robotics with human experience, promoting sustainable growth and more inclusive industrial ecosystem. So here is the conclusion of this, ultimately, the combination of IoT and machine learning will persistently stimulate progress and change in industrial procedure. Spanning from 4.0 to 5.0, the following list presents several potential study directions.
Kumar sir, are you done? Kumar sir? Kumar sir?
Hello, am I
Kumar sir, are
audible?
you done?
Hello, am I audible?
Yes, you are audible.
Actually, I lost
Have you
this
have
connection.
you completed your presentation?
My slide is still like visible to all of you.
Yeah, it's a conclusion slide.
Yeah.
Now it's a thank you slide.
Okay. These are the different areas where the people are working a little bit, have been done, and there's still few areas are untouched, like interoperability and compatibility with the other system. This is the major issue where where a significant work is not done yet. Although in energy efficiency, a lot of work has been done, like security and privacy has been done, but adaptive bandwidth, interoperability, and interportability are the still untouched area where the significant work is not done, and whatever the work is done, they are at the initial stage. So here is my presentation and the conclusion of this review exercise. Thank you so much for that.
Are you planning something for this untouched area?
Yes,
Just
yes, ma'am.
mentioned.
I'm still working for the energy efficiency and adaptive bandwidth, because interoperability and interportability require a lot of resources to work on that, and it requires a lot of funding. But by combining the machine learning technique and artificial intelligence, I'm trying to explore this. One of my research paper on energy efficiency has been selected in ESCI journal. Uh, but still, I try to work on adaptive bandwidth. The second objective of my research is this.
Thank you.
Thank you.
Mr. Kumar, can you give an example of IoT 4.0 which is being used in India or abroad?
Industry 4.0 is nowadays automated.
I'm asking any
Car.
application which has been done in India or abroad, which is widely used.
Like
have-
in car assembly lines, a few companies are actually enabling car assembly lines without any human intervention. The assembly lines will assemble the whole part. Like Kia Motors have recently adopted this thing. The whole assembly line will be like human free.
Okay, thank you.
Thank you so much, sir. Thank you so much to all of you.
Good afternoon. Hello. Is my voice is audible? Hello.
Yeah, hello.
Is my voice is audible?
Bhaskar sir, are you there?
Yes, sir.
Hello.
Yeah,
Hello.
Mr. Bhaskar.
Am I audible, sir?
Hello.
I am Bhaskar Sriranjani, sir.
Are you sharing the screen for Bhaskar sir?
Hello.
Hello.
Yes, sir. I'm ready to present, sir. Am I audible, sir?
No, you are audible, but what's your name?
Bhaskar Sriranjani.
Acha, okay, okay. You are Miss Bhaskar.
Miss. I'm Miss Bhaskar Sriranjani.
Okay, okay, okay. So, I'm sorry. And okay, you can share your screen.
Yes, sir.
Huh? हमने सबको करा हुआ है सबको.
Is it visible, sir?
Yes, it's visible. Please make it as a running mode. Yes.
A very good morning to all and all gathered here. Myself is Bhaskar Sriranjani. I'm a research scholar, Department of Mathematics,
You
from
can
Periyar.
you can zoom in the presentation, please. Presentation mode F5.
Is it visible, sir?
No, it is visible, but please press F5 for the running mode.
Is it okay, sir?
Please click on the icon which is close to that zoom button. Right corner, bottom right corner. Bottom right corner, there is an icon. Yes, just the icon beside it. No, before it. Just this one. This one. Click on this one. Please
This
click on.
one's a
Yes,
slideshow.
yes. Just click on that one. No, click on that on the slideshow. No, ma'am, please click on the slideshow icon, the left one. Yes.
Is it okay, sir?
It's not working. It is visible, but it cannot read anything. It's too small. Please zoom on the presentation.
Okay.
Okay, it's fine.
Okay, so uh, myself, Bhaskar Sriranjani, research scholar, Department of Mathematics from Periyar Maniamma Institute of Science and Technology, Tanjore from Tamil Nadu. My research topic is a novel kind of approach with one modulo 3 supermean labeling for enhancing communication efficiency in smart irrigation. This is my outline of the research. The present research explores the viability of one modulo 3 supermean labeling as a novel technique for communication networks for smart irrigation systems. This research involved the comparison of performance of one modulo 3 supermean labeling with several alternative algorithms such as genetic algorithm and ant colony optimization. Finding of this research, it suggests that the one modulo 3 supermean labeling offers a high performance in the comparative metasis. So this algorithm allows a reduce the latency by 95%, packet loss by 90%, improve the network throughput by 100%, and enhance the energy efficiency by 98%. So this performance is slightly higher than we compared to the genetic algorithm and the ant colony optimization. So therefore, the main conclusion of the study is identification of the significance significance of the research. So I would like to give some introduction about the topic. So in the last few years, the introduction of cutting edge technologies into the agriculture processes has changed the traditional farming approach, leading to the semblance of smart agriculture. So smart agriculture refers to the more productive, sustainable and efficient form of farming that is based on the implementation of the new production philosophies as well as the use of information and communication technologies. So among others, smart irrigation network have demonstrated the efficiency in water saving, enhanced yields, and less environmental impact. So to be more successful, the smart irrigation systems require a most sophisticated infrastructure such as the efficient communication network system. So we have some challenges in this system. So the network, what is the challenges means the network is to be installed. The need for such network is consume as little energy as possible. So the effective data transmission is first and foremost guarantees the minimum latency and high throughput make the decision of proper communication networks a challenging task. So to solve this task, we approach multiple techniques. The most popular optimization techniques, that is the theoretical genetic algorithm and anti-colony optimization. So these provide some feasible options, but the algorithms appeared not appropriate due to some dynamical nature of the environment and the complexity of the routing task. So in contrast, the one modulo 3 supermean labeling give a novel kind of approach. So a key premises of this method is that critical vertices and edges are to be appropriately labeled in the graph. By doing so, the network will be able to route the data more efficiently to and from a data sink. Specifically, the overall latency will be lower. The latency means the data delay of the transmission, and overall network throughput will be higher. So the network throughput means the data transmission will be successfully transmitted in a particular period of time. So our research is aimed to identify the optimal solution to the routing problems presented with smart irrigation networks by trailing them. So in this way, the one modulo 3 supermean labeling will be compared with the genetic algorithm and anti-colony optimization to identify the opportunities and constraints of the methodology. So these results will show the extent which the new methodology is superior. So this is a proposed methodology. The methodology presented in this research relies on the integration of different sensors, wireless communication, and advanced algorithms for the development and optimization of smart irrigation system. At the core of the system, we use three sensors, that is temperature sensor, water level or flow sensor, and humidity sensors. So these sensors are placed across the entire farming area and continuously monitor the environmental condition of one particular spot. So the accumulated data is used for the evaluation of the necessity of irrigation. So the labels are spread in such a way that when second node receives the data from the first node, repeatedly the process is transferred, the transfer of continuously transferred to the third node and so on. So perhaps the optimal way of the data transferring is calculated is based on the distance received from the first node. So this approach reduces the risk of the data packet loss due to the authentication of the signal at the first or second nodes. So simultaneously, it ensures the optimal organization of data transferring within the particular area. So what is we note in this point that the system only receives a data packet from sensors, but does not send this data back to the devices. So we have a data packet losses very minimum. So after the information, the numerous sensors is transferred to the controller. The optimization process is initiated via the wireless communication. So we defining the optimization process, that is the labeling referred as the 1 modulo 3 supermean labeling of graphs. So the controller creates the optimal communication network by labeling nodes in such a way what we created. So which is categorized by minimal latency, no interference, maximum data throughput, uh, data throughput. So conducting these analysis, if different sensors readings with the implementation in the real-time labeling process by the controller, the system optimize and prioritize the introduction of the irrigation process. So optimal and precise watering of the farming regions is guaranteed. So this optimize process also enhance the reliability of smart irrigation system and the WSN in general, and decrease the energy consumption of the nodes, which increases the longevity. So the controller uses the technique, the most irrigation functions effectively, which ensures the improvement of the crop yield and the introduction of some sustainable agriculture practices. So this is my labeling 1 modulo 3 supermean labeling. So when a graph is said to be a 1 modulo 3 supermean graph means it should be an injective function. So the injective function from a vertex set V of G to the set 0, 1, 2, 3 up to 3q minus 2. So these values are 1 modulo 3 values up to 3q minus 2 for the particular graph we taken. So q is the number of edges in the graph. At the step, each edge of the graph is labeled by some functions which is derived by the formula f star of v equal to v is f of u plus f of v divided by 2. If the functions is even, f star of e is equal to uv, that is f of u plus f of v plus 1 divided by 2. If the function we can add is odd. So by this formula, we can label the for any graph. So moreover, the modified labeling function refers the labels at the end points of u and v to assign a different and unique number to each edge. So which greatly ensures that the data is distinguished, and it gives a more precise description for routing and processing a network. So
And please
using this labeling.
yes, ma'am, please make it fast.
Okay, sir.
Please conclude it.
So this is the performance comparison with the other techniques. So performance matrices is latency, packet loss, network throughput, and energy efficiency. Compared with the other two algorithms, our labeling has data delay, that is latency is minimum, and packet loss, information loss is very minimum, that is 1. Network throughput is 100. So transmission of data with a period of time in which is maximum. So energy efficiency is also low. So obtained here we conclude that the obtained research results confirm the efficiency of 1 modulo 3 supermean labeling for enhancing the communication network performance, especially in smart irrigation application. So this performance slightly better performance compared to the other two algorithms, that is genetic algorithm and ant colony optimization. So for 1 modulo 3 supermean labeling, the method received the following performance scores, that is 95% for latency, 90% for packet loss, 100 for network throughput, and 98% for the energy efficiency. So we conclude that the result validate 1 modulo 3 supermean labeling as a new effective method, but also confirmed that it potential to revolutionize the smart irrigation system efficiency. So these are my references. Thank
So
you.
what simulation tool have you used in your work?
Sorry, ma'am.
Simulation, any modeling method, any simulation or programming? How you have verified it?
Ma'am, your voice is too break, ma'am.
Hello, she's asking, have you used simulation or not? Simulation or tools? What tools have you used to verify your data?
MATLAB tool. We're using MATLAB, sir.
So one thing, your presentation is very big. I mean, could have made a concise one,
Okay,
and
sir.
there are only paragraphs. There are no bullet points. So just putting your whole paper in your presentation is not a good idea.
Okay.
You have to make it very interesting and precise. So initially we were lost what we're trying to say. I mean, all the pages are filled with theory. So please, next time, please improve this thing.
Okay, sir. Sure, sir. I will do it, sir.
Thank you, Ms. Bhaskar. Thank you for your
Thank you.
presentation.
Thank you, sir.
Rahul, sir, are you there?
Hello. Hello.
Mr. Rahul?
Yes, sir. I'm there, sir. Hello.
Okay. So can you share your screen?
So is my voice is audible?
Yeah, you are audible.
Okay, sir. Okay. So first of all, good morning to all of everyone. So is my screen is visible? Hello.
Yes, you are visible. You can
Okay,
start your
sir.
presentation. You're
Okay.
having, you have to complete your presentation within 10 minutes, okay?
Okay, sir. Thank you, sir.
Within 10
So
minutes,
yes, sir. Sure, sir. So
please.
my topic, sir, I'm Rahul Pachori. I'm a graduate from Delhi Technological University in electrical engineering. My topic is IoT enabled smart EV charging infrastructure. So the main problem is in India right now is like we have there's very less EV chargers right now, and also we don't know which EV charger is empty and which is not, and like all the details also. So this particular project aims to develop a smart EV charging infrastructure leveraging IoT capabilities to enhance efficiency and user experience. Importance addressing the challenges of limited driving range and inadequate charging infrastructure for wider spread EV adoption. So the problem statement we have is limited driving range. People are reluctant to adapt EVs, range anxiety among potential EV users. This creates a wedge in this transition towards EVs. Inadequate charging infrastructure, insufficient numbers of public charging stations, uneven distribution of charging stations in urban and rural areas. Long waiting times at public charging station that we all know. So this is our proposed model, an EV charger with an IoT smart monitoring system that we have installed in our college itself. EV charger, it delivers power to the EV, supports multiple charging speeds, includes safety features. IoT monitoring system. In this, we have connected different type of sensors: current, voltage sensor, temperature, proximity microcontroller, central processing data collection system, Wi-Fi connection modules. We have used for the IoT model system, we have used the ESP32 modules, and for user interface, we have used Blink IoT app, and the website we have make it on. So this is our EV charger development, design development, and we have made our own PCB for this charger. We have used Arduino Pro Mini for the all the communication protocols here. So this is our IoT monitoring system. In this, we have used various sensors, voltage sensor, current sensors, and industrial level temperature sensor also. If the temperature goes above a certain level, then it will automatically turn off the EV station. So this is our this is our result and decision like we have installed, and after installing it all, we have getting all the data parameters in our Blink IoT app on our web page also on our phone also, sir. So in the conclusion, the development of an IoT-enabled EV charger system infrastructure addresses the key challenges such as limit driving range and inadequate charging stations. By integrating real-time monitoring system and user-friendly interface, this system enhances efficiency, user experience, and connectivity. So, if you have an EV car, like you put you put the charger and go into your home, but our system will tells you how much voltage is going into the charger and how much is the temperature and how much power is conserved by the charger also. So you have you don't take care of anything like in the home also you can turn off and turn on the charger also. by only sitting in the home. No, you don't have to go to the car and just plug out the charger and all. So for the future enhancements, renewable energy integration, solar panels, we have decided to integrate the solar energy systems and use batteries to access energy, and advanced data analytics to make if we have like in Delhi we have all the EV charger station connected together and making it online web page so that we can see like how much how EV charger is free and not. So thank you, sir.
Thank you. So you were talking about this temperature data. So temperature of what? Vehicle, battery, or are we talking about the temperature of environment?
So we have used two temperature sensors. First, the temperature of the charger, because the temperature is very mean. If there is any mishappening with the charger, then the car also goes down. And the one temperature sensor is in the car also. If there is a difference in the temperature after a certain level, then the charger will shut down from the grid supply.
So how will you make sure that the sensor in the car matches your equipment? I mean, is there any protocol for that?
Yes, the sensor we have used is an industrial level sensor. We only have to connect the probe to the car. After connecting the probe, we did not connect it with any communication protocol, because if we connect that temperature sensor to any communication protocol, then there is always there is an error. The small error also, but there is an error. So we just only connected the sensor. It is an industrial sensor. We put the value by ourselves. If after 56 degrees Celsius, the car is not very safe. So we will just put 56 degrees Celsius in the temperature sensor. So after that, if the temperature goes above 56 degrees Celsius, the car and the charger will shut down.
So if it's very hot, like in June, May, June, then we cannot charge our cars with this.
Yes sir, if the, we have to set a parameter, if 60 and 65, we have to set it.
You're talking about cloud transmission of data. So
Yes sir.
why it is required to for cloud? You know, like if it's a local system, so why are you transferring the data to cloud? And how will
No
you
sir,
pay for that cloud?
the temperature sensors is not on the cloud, but the voltage sensor and the current sensors are on the cloud based. We have connected ZMPT and CT current sensors, probe sensor, to the ESP32, and that ESP32 is connected to the Wi-Fi of your home and anywhere else. So we just get the data on the cloud from the ESP32.
What is the expected cost of this equipment you're planning?
So the IoT, if we talk about the monitoring system only, then it's 2000 and 3000 only, because we wanted to make something like everyone can afford that thing, like a charger also everyone can afford that, and the monitoring system also, because the monitoring system is something there is requirement anywhere, because we can say there are many scooties, bikes, and their charger is just plug and play, but there is no safety precautions they in the bigger companies. There are Ola have their safety features, but the small companies did not give any. They just connect the charger and charged. So in that system we can use our Mori system, and for the charger the cost is around 15,000.
Okay, thank you.
Thank you sir. Thank you so much sir.
Thank you all for your presentations, and I really thank the session chairs for giving us their precious time. Thank you, Divya ma'am, and thank you, Sada sir, for being with us. Thank you so much.